Hello my dear students, can you factorize this algebraic expression? Looking at that, we have 4 terms and currently we don't know what to do. So let us try to group the terms. Let me group these 2 and these 2 and see if they have any common factor. The LCM of these 2 is A here we have common and X we have common. So let's take AX outside, open bracket, and AX is taken outside, so we have BX inside plus A and X has been removed, so this much plus, here I can see B is common and nothing else is common. So let's take B outside. I have BX plus A. So inside I found BX plus A common. So let's put BX plus A here multiplied by AX plus B according to distributive property of multiplication over addition. Now we have factorized this big algebraic expression into 2 factors. Here I have another problem, 3ax minus 6a minus 8by plus 4bx. How can we group? Let us group these 2 and these 2 and see what is the LCM of these 2 terms. So 3 is common, a is common. When we take it out, what remains inside is x minus 2y, and here I am trying to get the same x minus 2y here, so I can see 4 being common and b being common. Let me put the plus sign, and here I have minus 2y plus x remaining. X minus 2y same as minus 2y plus x, so we can write this as x minus 2y into 3a plus 4b. Using the distributive property, we have factorized this algebraic expression by grouping. Here we have another algebraic expression. By looking at it, I'll straight away start grouping. This looks similar here also, and I don't know what to do with these, so let's keep it as it is. Those who are not aware what is this horizontal line, this is called vinculum, which is like a bracket, the innermost one usually. And here I can see that I'll take out x square, then I am left with x minus 1, then I'll do plus, and here I have x a plus 1 and minus a minus 1. Now I will rewrite this as x square x minus 1 plus x into a plus 1 minus 1 into a plus 1. I'm taking this whole thing into the bracket and multiplying by minus 1. Now I have a plus 1 and a plus 1 common here. So what I can do is x square x minus 1 plus a plus 1 into this one as x minus 1. Now I have x minus 1 common here. I can write x minus 1 into x square plus a plus 1. Now we have the factors of this algebraic expression as x minus 1 into x square plus a plus 1. Let's rewrite the whole thing. Now x cube minus x square plus, here I am going to group a with this a, so ax minus a comes here and this x will be taken that side. Now I see that x cube minus x square, they can still be a group. This can be our new group, and let's see what happens. This is equal to x square can be taken out, x minus 1 remains inside, plus a can be taken out, x minus 1 remains inside, plus x minus 1 is here. I can see that here in 2 terms we have x minus 1 common, and here x minus 1 is written separately. So what I can do is I'll put them inside one bracket and multiply by 1 so that I get this as a new term with the x minus 1 common factor for all these. So now we can take x minus 1 outside and we are left with x square plus a plus 1, and we cannot further simplify this. That is why this is the factorization of this expression. Here I have another algebraic expression where I don't see anything common. See what we can do first. We can see that we can multiply and expand it. First let's try to do this. Here ab x square plus ab y square minus xy a square plus xy b square. This is minus because I am multiplying by minus x square. So here let's see if we can group similar things. So here I can group these two and these two and see what happens. ab x square minus, I'll write it as a square xy plus ab y square minus b square xy. Now I can see we have new common factor, that is a and x. Here we are left with bx inside the bracket minus ay inside the bracket. Here again we can see b is a common factor and y is also a common factor. We can say that ay minus bx is what we are left with inside the bracket. Here we can see that here bx minus ay is there and here ay minus bx is there, the reverse of it. How can I change to the same thing? If I multiply this by minus 1 and minus 1, we'll be able to change it, but to keep the value intact I have to do that outside also. So that means I have to do ax into bx minus ay minus by into minus ay plus bx. Now this is same as this. After that we can write this as bx minus ay into ax minus by. This is the factorization of this algebraic expression giving these two factors. Here I have an algebraic expression with lots of terms. Let us try to group. So first I'll keep 1 as is, then all the x's I group, then I'll have x plus xy minus zx minus xyz, and what remains is plus y minus z minus yz. Now we can say that all these have x as a common factor. So let me take out x. So 1 plus x into 1 plus y minus z minus yz plus y minus z minus yz. If I carefully observe, I see these three terms and these three terms are common, but this one is extra. So what I will do is I'll keep this one outside for now, means 1 plus x into 1 I'll keep outside as x only, plus from only these I'll take the x out, z minus yz, and this one I'll show as 1 into y minus z minus yz. Now having y minus z minus yz common in these two terms, I can take that out. 1 plus x remains as it is, plus y minus z minus yz, and this becomes x plus 1. Further observation shows me that this x plus 1 is common here and here, so I will write this as 1 into x plus 1. So then I'll be able to take x plus 1 outside, which gives me 1 plus this thing remains as is, y minus z minus yz. Now here I see y is common and in this case z is common. Let me take out the y by grouping these two. X plus 1 into 1 plus y, I'll take 1 minus z and minus z remains. I can write this as x plus 1 into this 1 minus z, I'll group together, 1 minus z plus y into 1 minus z. This and this I have grouped. So then again I can see 1 minus z is common. So I can write x plus 1 into 1 minus z. Here what remains is 1 plus y. Rearranging this, I'll get is equal to x 1 plus x, I'll write, into 1 plus y into 1 minus z. These are the factors of this algebraic expression. So I'll change the grouping this time. I'll write it as 1 plus x, and here I'll group this y and this xy plus y plus xy. Then I have this minus z. Instead of grouping this with this, I'm going to group it with this. So minus zx, and this one will be minus yz minus xyz. We can see that 1 plus x we have, plus y can be taken out, 1 plus x remains, minus z can be taken out, and 1 plus x remains, and here minus yz can be taken out, where 1 plus x remains. This is a better way of grouping. So here we got this, I can group and say 1 into this. So 1 plus x I can take out as a common factor of all these terms. Then I have 1 plus y minus z minus yz. This is 1 plus x into 1 plus y minus z into 1 plus y. Again I can group this and say that this is 1 into 1 plus y. That is why I get this as 1 plus x into 1 plus y into 1 minus z. By grouping in different ways, we got the same set of factors for the algebraic expressions. This means that the grouping can be done in different ways, not necessarily be the optimal way. Some groupings may take us to the answer in fewer steps, some may take us to the answer with more number of steps. By solving more number of problems, you will be able to identify the optimal method of grouping. So keep practicing, keep solving as many problems as you can. So all the problems we solved are from R.S. Agarwal class 9 mathematics, and page 291 exercise 9a we solved question 20, 21, 22 and 24, and also saw the example problem at the end. If you found this video helpful, please subscribe to the channel, press the bell icon to get notifications. Love maths.